Hi, and welcome to math class. In this lesson, we are going to be looking at vocabulary. These are terms that you really must know to be able to do fractions. And if you have the toolkit, you have this piece in your toolkit. Let me check to see which number it is. It is item number 7 in the toolkit. So if you have this one, you also have flashcards with these same terms on them. And I gave you the flashcards. I strongly recommend that you write these in both places. We're going to put this in the notebook, but the flashcards also need to be done to help you learn these terms. As you're practicing your flashcards, you want these to be worked in there. So here is the memory piece. This is item number 7. And I'm going to walk you through how to work with this piece. Hopefully you have cut this piece out and it's just lying there on your desk. So walk through this with me. I will do it slowly. You're going to need some scissors and some glue to put this piece down in your book. The first thing you should do, if you haven't already, is to cut, and let me see if I can make this work. You want to cut out this piece. So you're going to cut around the edges of this piece. These blue lines are cut lines. So you cut out this piece. Cut on the blue. Once you get that done, you've cut that out, and you can stop the video if you need to until you've cut this out. I want you to cut on these lines. 1, 2, notice I'm not cutting across that middle piece. 3, 4, 5, 6 cuts there. So you don't cut all the way across. You're not cutting these up like flashcards. We want them to stay attached to that middle spine. Okay. So now you have, these are like piano keys that lift up. Now I want you to turn your piece over and put glue on this part. You're going to glue this spine on the back, not where you see the words, but on the back. You're going to glue this down to your notebook. Okay, so you have all of those pieces that are flaps that lift up, little doors. The glue goes on the back of this blue area, and then it will stick to your notebook. And you can position it however you want to in your notebook. The reason I did it this way, I know this is a little complicated. I want you to be able to sort of quiz yourself on this exercise. Now this is different than flashcards. Flashcards are to teach you lots and lots of math vocabulary. This is to quiz yourself just on fractions. So as you lift these doors up, you should know, with time, you should know the answers underneath them, what the terms under there mean. And that's what we're going to do today. I'm going to give you the definitions of these terms. So first thing we want to do is label our page, and this is called fraction terms. So hopefully you have your little memory piece stuck down there. And we're going to start with numerator. So I want you to lift up your numerator door. We're going to write underneath the numerator door. And I'm taking my term out, so pretend that I have opened up this door and I'm looking underneath it. The little door just folds back and we're looking at that space underneath. Here is the definition of numerator. It is the top number of a fraction. And on the flashcards, that's all I would put. I would not copy all of this again. I would just put this on the numerator flashcard. But since we're defining this and we're taking notes here, I do want to add some here. It tells how many parts of the whole meet a given condition. And I am going to give you some examples here. So let's draw ourselves a box. Doesn't have to be perfect. And I want you to cut that box into 4 pieces. And if you're using highlighters or whatever, you can color it in, or just with your pencil is fine. But I want you to color in one of those boxes. Okay. So we could say that 1 out of 4 parts are blue, that 3 out of 4 are not blue or not shaded. If you're shading, we could, if you don't have a blue pen, let's say shaded or not shaded. So that numerator is telling you the given condition. It's either shaded or not shaded. And the numerator, the top number, is what tells you how many fit the description that you're looking for. That's numerator. Okay, denominator. Let me get rid of this. I'm just erasing that out of there. Denominator is the bottom number of a fraction. And for your flashcards, that's enough. You don't have to add any more than that. But for your notes, for your quiz piece, let's add more information. The bottom number of a fraction. The denominator has a very important job. It tells the number of parts, let's say the number of equal parts, in the whole. So let's draw a picture. Let's do a square or a box. Doesn't have to be perfect. I need to straighten mine up a little bit. Okay, whoa. So this is a box with how many equal parts? 4. It has 4. Pretend that they're equal. So any fraction of this box would have a denominator of 4. There will be a 4 on the bottom. There could be anything on the top, but there will be a 4 on the bottom. So if I were to shade one of these, just like I did above, I would say that 1/4 is blue, that 3/4 is not blue, but you notice that denominator, the 4, doesn't change because the 4 parts in the box don't change. Now let me show you something here. Let's draw another box and cut it into 3 parts. So let me ask you this question. Could I say that 1/3 is shaded? What do you think? Is 1/3 blue? The answer is no, because the parts of the whole are not equal. The parts of the whole must be equal for us to make a denominator. And unless we have equal parts, we cannot use the number as the denominator. So I don't want you to think that just because something is cut up a bunch of ways that that's automatically a denominator. Remember that a denominator has equal parts in a whole. So numerator is the top, denominator is the bottom. Denominator is down, it's the bottom. Okay, a proper fraction. Let's take a look at what this one means. This is a very important, all of these are important. So let me, remember I'm erasing, but you raise the door up. You don't want to mark out your proper fraction. Just pick the door up and let's write on the paper underneath. A proper fraction is a fraction that has, I do that every time, don't I? A fraction that has a numerator, and remember numerator is the top, that is smaller than the denominator. And remember the denominator is on the bottom. When I was in school, I thought of these as bottom-heavy fractions. So here's an example. Let's just use our familiar box, if I can get it to draw again, and then cut it into 4 equal parts. Pretend they're equal. I can't get them straight today for some reason. And I'm going to color one of them again. So the blue part there is 1/4. That is a proper fraction. What if I color another one? What would the fraction be? How many blue ones out of 4? That would be 2/4. That is a proper fraction. 3/4. Would that be proper? Sure it would. But look what happens when I get to 4/4. This is no longer proper because the bottom and the top are not different. They're the same. So this is not a proper fraction. As soon as you reach the point of 1/2, just like I have here, 4/4 is the whole thing. It is not proper. But these three are proper fractions because they are less than 1/2. So really, when I define a proper fraction, if I were doing this on my flashcard, this is all I need to know, that it is less than 1/2. Anything less than a whole is a proper fraction. So if that's a proper fraction, what do you think an improper fraction would be? Well, let's write the definition. And then on your flashcards, I would use the short version. I don't think you need to write all of this twice, but I definitely would put the flashcards in with my study packet. An improper fraction is a fraction that has a numerator and remember numerator is top that is bigger than the denominator, the bottom. This is a top-heavy fraction. Okay, so to illustrate this one for you, let's just stick with our box here. I want you to draw a box and cut it into 4 parts. And then I want you to make another one just like it. And I'm going to have to draw that separately, aren't I? Oh boy, it needs to be exactly the same. So let me try this again. I just want to copy this part. Okay, there we go. It did work. Kinda. Let me erase this part. Okay, so this is what I needed. 2 identical boxes, and let's color them. So here's 1/4. That is a proper fraction. 2/4, still a proper fraction. 3/4, still a proper fraction. 4/4, remember this is where things change. This is a whole. So we can say that 4/4 is 1 whole box. So let's suppose that this was pizza, individual pizzas. And I ate 4/4 of one pizza, and then I just kept eating. So maybe I ate another 1/4 of this pizza. So I ate 4/4, the whole first one, and then 1/4 of this one. That's a total of 5/4 that I ate. Here's 1, 2, 3, 4, 5/4 that I ate. This is an improper fraction. It's top heavy. It is a fraction that is greater than 1 whole. And this is what I would put on my flashcard. Rather than write all this out, an improper fraction is greater than 1 whole. I might also put that it's top heavy. And up here I probably would put that this one is bottom heavy. Okay, so you have learned numerator, denominator, proper, and improper. All right. The next one is mixed number. And so let me get up here where I can work with this one. Mixed number. And it gives you a clue about its definition just in the phrase mixed. Something is mixed together. So this one, I'm reading my notes so I tell you exactly what I need to tell you. A mixed number is a number that has a whole part and a fraction part. And I want to give you two examples. The first one I want to give you is this one. I want you to draw a dollar bill. Okay, so that's $1. And then I want you to draw me another one just like it. So pretend that these are dollars, dollar bills. And just ignore me. I've messed up my picture, so bear with. There we go. So here's $1, and there's another one. So I go to the store or to the Taco Bell and I buy a taco that costs $1.50. So I don't need all of this dollar. I only need half of it. Now in this case, we wouldn't rip this dollar bill apart. You would give the clerk 50 cents. Okay, so that would be $1.50. $1.50 is $1.50. But if you wrote it as a fraction, you would say 1 whole dollar and half of another dollar. $1.50 is $1.50. That is equal to 1.50. This is a mixed number. It's got a whole dollar mixed with a half of a dollar. Okay, here's another example. Let's go back to our individual pizzas. Have you noticed that all my stories are about food? Pizzas are perfect for teaching fractions. So let's draw ourselves the same diagram, and I'm going to try to cut it. It needs to be exactly the same. That's the thing about mixed numbers. You have to have two identical pieces to start with. Let's try cropping that. or you don't have a mixed number. So you have to be very careful that you get the, oh boy, this is not working like I wanted it to. The problem is that I have all of that where I've whited out my pieces. Bear with me, guys. There we go. This is what I'm trying to get to. Sometimes technology is not my friend. Alright, I'm just going to have to go with this, I think. So I have these two identical pizzas, and I eat 4/4. So let's color that to show that it's gone. I ate 4/4. I ate the whole pizza. One whole pizza. 4/4. And then I still kept eating, and I ate another piece out of this next pizza. I didn't eat two whole pizzas, but I ate another piece. So I ate 5/4, just like we did in that last problem. Or you could say that as one whole pizza and 1/4 of another pizza. 1 and 1/4 is the same as 5/4. 1 and 1/4 is a mixed number. 5/4 is an improper fraction. So for every mixed number, there is an improper fraction. If we went back to this example, the improper fraction would be 1/2, 2/2, there's the whole, 3/2. So for every mixed number, there is an improper fraction. And when we get into the actual calculation of these problems, we'll have to go back and forth between those two forms. And I'll teach you how to do that when the time comes. Right now, it's not that important to know how to do that. Right now, we're just learning the terms. Okay, equivalent fractions. And we know that equivalent means equal. So let me white out this part so that I can write the definition. You just raise up the door and write underneath it. Equivalent fractions are fractions of different terms that have the same value. And this time I'm going to use circles. And I'll tell you what, rather than go through what I did just a minute ago, I'm going to come over to this page and draw my circles. I'm getting a low battery. I need to put my cord into my iPad. So I'm going to draw this one, and then I'm going to copy it and draw this one. But this one I'm going to divide a little bit further. So instead of making, and I know I'm asking you to draw these with me. I wish I could have given you a workbook where they're already drawn, but here we go. So this is close enough. If you will just sketch yourself one of those, and I'm going to plug in my cord for my iPad so we don't lose battery power. And then I'm going to bring these back over to my workspace. but this will save me from messing up my whiteout. So here we go. Alright, let's study these two pictures for just a minute. The first one is divided into 4 equal parts. So this denominator would be a 4. This one is divided into 8 equal parts. So think of these as pizzas. The first pizza serves 4 people. The second pizza serves 8 people. Because in the first pizza, the slices are bigger. They're twice as big. So these are the terms of the fractions. The first one is in fourths and the second one is in eighths. So let's start eating pizza. Here is 1/4, 2/4, 3/4. So let's say that I ate 3 out of those 4 parts. I ate 3/4 of that pizza. And you ate 1/8, 2/8, 3/8, 4/8, 5/8, 6/8 of your pizza. Because those pizzas were the same size, we ate exactly the same amount of pizza. So if the pizzas were identical, I ate the same amount of calories as you did. They're different pizzas and they're in different terms, but they are equivalent fractions. They are the same amount of pizza. So they're fractions of different terms that have the same value. 3/4 equals 6/8. The next one is lowest terms. So let's take a look at lowest terms and see what that means. Lowest terms. A fraction that cannot be reduced any further. And to show you this one, I'm going to draw over here again. I want to take a circle and cut it in half. And then I'm going to copy it so that I have another one to show you. And this one, it's the same size circle, but I'm going to cut it into eighths. Okay, so these are the two that I'm going to use to show you this definition. So let's put them right here. I have 2 identical circles. One of them is in terms of half, and one of them is in terms of eighths. And I'm going to start with the eighth. Okay. I want you to shade with me 4/8 of this circle. 4 parts out of 8. So 4/8. And then in the other one, I want you to shade 1/2. 1 out of 2. One of these fractions is lowest terms. One of them is not. This one, the bottom one, is not lowest terms. because I could take away some of the lines inside that circle without changing the fraction, without changing the yellow amount. But in this one, if I take away the lines inside the circle, I no longer have a fraction. That one is lowest terms. It cannot be reduced any further and still have a fraction. This bottom one, I could erase two of those lines and still have a fraction. I would still have a half. And here's the connection there. If I take 4/8 and I erased two of the lines in here, so maybe I erased that one and I erased that one and I erased that one. Let's erase three of them. I would get back to that half. Okay, so what I'm doing, I am taking, I'm dividing in this case by 4. 4 into 4 is 1, 4 into 8 is 2. This is the lowest terms version. 4/8 can be reduced. 1/2 cannot be reduced. And finally, a unit fraction. Anytime you see the word unit in math, think of the number 1. Unit 1. So a unit fraction is a fraction. It's a special type of fraction. Let me just go ahead and write the definition for you. It is a fraction with a 1. In the numerator or the denominator. It can show up in either place. And I'll show you examples of both of those. And let's underline the word or. So what if I told you that one cookie costs $2.50? One cookie, $2.50. That is a unit fraction. It tells me the price per unit, the price per cookie. Or I might tell you that I get 29 miles per gallon. That's for 1 gallon. That is the unit in this case. It's gallons. And we have room for one more. Let's say that 1/2 cup of rice serves one person. So in this case, the unit is a person. And these fractions can look very complicated. They can have decimals, they can have fractions in fractions. It can get pretty complicated. But what you want to look for is that your unit fraction has a 1 in either the numerator or the denominator. If one of the numbers is a 1, you have a unit fraction. Okay, now that you are an expert on fraction terms, we will get into the lesson about how to work with fractions, and you'll be hearing these terms coming up over and over as we go through those. So I encourage you to come back to this page often. Raise those little doors up and review this material. That's why I didn't just have you to write all this down. I want you to come back to this and use those little doors as a quiz method. So look at the picture of the word numerator and see if you can picture in your mind what is underneath that door. And that will help you learn this material and help you commit it to memory so that you will never forget it. It's also good if you're a hands-on learner so that your hands are active in your learning process. I will see you in the next video where we'll start doing math with fractions, and I hope that you have a really good day. Bye-bye.